In this video, we're going to explore the sign of our trig ratios, whether they be positive or negative, and kind of relate that to the quadrant in which our angle terminates. And so in our previous video, we saw that we certainly are reimagining our trig ratios based on an angle being in standard position, intersecting a circle of radius r at this point, x, y. And it always allows us to kind of create this little right triangle right here where we know the x, we know the y, we can go solve for r. But some things here. Remember that given this angle here, the sine of this angle is always going to be y over r. The cosine is always going to be adjacent, or x over r. And then we would say tangent's opposite over adjacent, y over x. So given these ratios here, something is really, really apparent at first. If you terminate in a different quadrant, say than the first quadrant here, you may have positive x's, but you may have negative x's, or positive y's, or negative y's. The only exception to this, you could be positive or negative rule, is just that r is always a positive thing here. So what we're going to do is kind of explore what should I expect to be positive and what should I expect to be negative in each of these four quadrants right here. And so really quickly, let's just kind of explore sine. Where would sine ever be positive? Given the fact that r is always positive, then we could kind of deduce that sine would only ever be positive if the y part of this was positive. So where are y values positive in the xy coordinate plane? Well, that'd be in your first quadrant and your second quadrant. That means that any angle that terminates in your first quadrant or that terminates in your second quadrant has to have a positive sine value. Likewise, where's cosine going to be positive, given that r is always positive? Well, the only way cosine is going to be positive is if the x part is also positive. So in which quadrants would we expect to see cosine be positive? Well, where our x value is positive, that would be in the first quadrant here, we have positive x's. But also in the fourth quadrant, if we had any angle terminate down here, its cosine value would have to be positive because it has positive x values, and cosine is x over r. So we see cosine being positive to the right of the y-axis. How about tangent? Well, tangent is y divided by x, and given that y or x can both either be positive or negative, the only way tangent's ever positive is if y over x is a positive divided by a positive, and so tangent is also positive up in the first quadrant here, but also a negative divided by a negative, so it could be in the third quadrant. So an easy way to remember this is to remember the mnemonic, all students take calculus. And this is just a really, really quick mnemonic where we kind of memorize the first letters here in each quadrant. A, S, T, C. But what this really stands for is that in the first quadrant, if you terminate here, all of your trig functions are positive because x is positive, y is positive, and y over x will also be positive. Everybody's got to be positive if you terminate in the first quadrant. If your angle terminates in the second quadrant, what's going to be positive? Well, S, and S is for sine. You can see that sine is y over r. We have positive y values, so our sine value would be positive. And likewise, its reciprocal would also be positive. But our cosine value, having a negative x value here, would be negative. And our tangent, which is a positive over a negative in this case, would also be negative. So this S kind of indicates that sine should be the only thing that's positive in the second quadrant. That kind of implies also that down here, this T would imply that tangent's the only thing that's positive. Negative over a negative is a positive. But negative y and negative x guarantee we get a negative sine and a negative cosine on their own. And then this C is kind of short for cosine, so cosine would be positive here. So in large part, we're going to engage in practices where we kind of try to determine what angle what quadrant our angle must have terminated in, given the signs of our ratios here. So looking at number 9, it says, hey, cosine is greater than 0 and sine is less than 0. I want you to understand that this is a fancy way of me telling you that cosine here is positive. Okay, so cosine's positive, sine is negative in this case. I always draw this little diagram right here, but what I'm trying to do is narrow it down. If cosine is positive, where might we lie? And so knowing that A stands for all, cosine could be positive in the first quadrant, but it could also be positive in the fourth quadrant, the C standing for cosine. Where it couldn't be is it couldn't be in the second or third quadrant, because if cosine is positive, well, cosine is negative over here, so we couldn't terminate there. So of the two remaining quadrants, we say, well, sine has to be negative, so which one of these should I cross off here? Where is sine going to be negative at? Well, if sine is negative, I couldn't be in the first quadrant. That means that I have to be in the fourth quadrant here. So this is kind of an exercise in, could we narrow it down? Let's take a look at number 12 here. Number 12, I'll just make my all students take calculus diagram here. What quadrant could we be in if cosine is negative and cosecant is negative? Well, first things first, for cosine to be negative, okay, we would have to be able to cross off a couple of quadrants that wouldn't apply here. So I'm going to cross off, the quadrants where cosine is positive, because if cosine is negative, I could not have lied there and there. Now, as far as cosecant being negative goes, that doesn't really fit this ASTC thing because cosecant's not part of this mnemonic. But what do we know about cosecant? it's the reciprocal of sine. And if cosecant is negative, then its reciprocal also has to be negative. So I'm going to write this right underneath it. Well, then it also follows that sine is negative. And out of these two remaining quadrants, if sine is negative, where would we have to, be? I couldn't be in the second quadrant because sine's positive there. This must be in the third quadrant. So again, we'll try one more really quickly here. If cotangent's positive, then it's reciprocal. Tangent is also positive, and sine is negative. So where could we be? Well, I know that if tangent is positive, then I couldn't be here or here. I would have to be either in the A or the T. And of the two remaining quadrants, if sine has to be negative, then I couldn't be up here. This one also is in the third quadrant. So I want you guys to assess the situation, see what you can find out about your positivity or negativity based on the angle in which theta quadrants, the quadrant in which the angle theta terminates.